Alright, so we've been talking a long time about transactions without actually teaching you the syntax for how do you actually write transactions into SQL. It's probably been like you guys are going, oh gosh, we're talking about read and write actions, and we're talking about getting unlocks and unlocks. How do you actually do that in SQL? That's what this video is about. Okay, so the way that things work in SQL is a transaction starts with a begin statement, which defines what type of transaction we're doing. We'll talk about those types in a little bit. Then there are the statements within the transaction, like the various reads and writes. Now, what is a read database action? Well, it's really a select statement. What is a write database action? Well, it's like an insert or a delete or an update, something that changes a table. And then the transaction can end in a couple different ways. One way that it can end is with a commit statement saying, hey, all of the changes that I've made during my transaction, I'm done. Make those happen to the database now, because all of those reads and writes were kind of in a temporary fashion until you do the commit, which says, hey, make this permanent. The other way things can end is with a rollback statement. A rollback statement basically says, abort, stop doing this, and it means undo all of my temporary changes to the database and act like this transaction never happened. This is the way that transactions guarantee atomicity. You either commit and you're done and you can make the changes permanently to the database, or you roll back and abort and it's like the transaction never happened. Another way that a transaction can end is with an error. And if a transaction gives an error, it's the same thing as causing a rollback. If for some reason your transaction is trying to do something illegal, then it will cause that transaction to roll back. And we'll get to that a little bit later in the lectures. Okay, so what's the actual notation for this? Well, you begin a transaction with the begin transaction statement. You finish a transaction with the commit transaction statement. So what does this code look like? Well, you have begin transaction, you have your inserts and updates, deletes and reads and so forth, the normal SQL statements in between. Then you have your commit transaction. That's an entire transaction right there. And you might be going, wait a second, if we're supposed to do all of our code with transactions, why are we only learning about them now? It seems like all of the code that we've written before this point, we haven't been doing them in transactions. And you'd be half right. So one thing that SQLite and many other databases do is they have what's called an auto commit. So by default, SQL and many other database management systems commit after every statement. They begin a transaction right before your statement and then commit afterwards. And that's why, especially in your examples, when you do a read and then it commits, and you do a write and then it commits, and then you do another write and then it commits. It does that before on your behalf. Every statement is its own one-statement transaction. However, when you explicitly say begin transaction, this turns off auto commit mode until you commit the transaction or until you roll back the transaction. Then it goes back into auto commit mode until you explicitly say begin transaction. And so what sort of things would you stick within a transaction? Well, you stick the things within a transaction that care about the state of the data before and after. So the things that you'd want to stick in a transaction are things like, hey, I need to read somebody's financial information, and then I need to increment it by 100 if that person, got the job. And what you wouldn't want to do is you wouldn't want any other transactions, any other people using the database to be able to change that person's financial information between when you've read from the data and when you need to write your new result to the data. And so you'd begin a transaction to say, hey, nobody else is allowed to mess with this data. I'm working with it right now. And then you'd finish your transaction with your write, and you'd commit, and you'd be done. So back to auto commit. The SQLite Python module sometimes tries to be really helpful. It tries to automatically add begins and commits for you, because in reality, most of the people using SQLite aren't really doing a lot of complicated stuff with transactions. They just want to run their statements as soon as they are able to type them in. But what we're going to do is we're going to turn that mode off, so that we can actually write explicit transactions without having the SQLite Python 3 module trying to get in our way. The other thing to note is the Python SQLite module has commit and rollback methods. If you're reading the documentation, you can see, hey, if I could say connection.commit or connection.rollback methods, you should not use them in this class. In fact, they work in a kind of peculiar way that doesn't interact nicely with actually writing SQL transaction statements, writing like the begin transaction semicolon stuff. They don't play nicely with each other. So for the purpose of this class, you can pretend that those methods don't exist. I'm only going to talk about them here just to tell you to shy away from them. Okay, so let's look at some code that uses transactions. So we're writing Python code here. We import SQLite 3, and what I've done is I've made two different connection objects. Connection 1 I'm highlighting in blue just so that you can tell them apart. Obviously, the color doesn't mean anything other than just to help illustrate. They both connect to the same database file, and they both have isolation level equals none. This basically says turn off the SQLite 3's like wanting to stick begins and commits all over the place silently on your behalf. It basically says, hey, these transactions should not be allowed to talk to each other in any way. And so you have to pass in that explicit flag to make that happen. And then let's start doing some stuff with connection 1. So for instance, we might drop the table students if it exists. This is just to clean up our database if we're rerunning this code over and over. We create a table called students with one column name. We insert Grant into our student table. Okay. And now these are all in auto commit mode. Basically, after each statement, we're committing. Drop the table if it exists. Commit. Create the table if it exists. Commit. Insert into table students the name Grant. Commit. Oh, and now what we're going to do is let's start doing some stuff with transactions. For instance, I could say connection 1, begin transaction. And then I say insert into students Josh. And now note, unlike before, there isn't a commit at the end of this insert statement. This commit is only present for connection 1 until you actually say commit. So this means that, for instance, if we have connection 2 that's beginning its transaction, and it does select star from students, what students does it get back? Well, it gets back Grant because that was committed, but it doesn't get back Josh because the inserting Josh into students was not committed yet. So connection 2 only sees Grant. That's the whole point of these transactions. You don't get to see the changes that other transactions do until they commit. However, if we go back to connection 1 and we do a select statement from students there, it will see both Grant and Josh because connection 1 has written to the database and it can see both the insertion of Grant and the insertion of Josh. And then we can end both statements or both transactions by committing both of them. And after we've committed transaction 2 and transaction 1, now both connections will be able to see the change that connection 1 did to the database. Both of them, after these two statements, will be able to see Grant and Josh are both in the database. Okay, so this is how you use SQLite 3 to do transactions. They're just other sorts of SQL statements that you use the execute method on, but they have interesting implications for instance, what does select return, or what sort of data are you inserting into a database? Okay, so in the previous example, it was a little bit strange. For instance, we had one thread, one Python script that had two connections to the database. And so this is actually a little bit unusual because usually one application will only need one connection to the database. You're not going to have like this application trying to have multiple connections to the same database and doing things like it's schizophrenic. So normally what you would do is different people or different programs would be talking to the same database, and because SQLite uses locking to ensure that you can get serializability, multiple different transactions would not be able to commit different database writes at the same time because only one of those transactions would be granted the exclusive lock. And so the way that a connection, when it's trying to get a lock and it can't get it, what it does is it normally waits. It says, okay, I want to get a write lock, I want to get an exclusive lock, but I can't because this other connection has that lock, and I'm going to wait for it to get done. And you could wait forever, because if that other transaction is just like never is going to give up the lock, is never going to finish, is never going to commit a rollback, you could be waiting forever. So the way SQLite handles that is they have what's called a timeout that says, hey, if you're waiting for a lock for more than a certain period of time, by default 5 seconds, then you would just fail. You'd raise an error and say, I couldn't get the lock, roll back all the stuff I've been doing. And this normally isn't a big deal because transactions take, usually less than a second to run. And so if you have to wait for more than 5 seconds to get a lock, it probably means you probably aren't going to get the lock anytime soon. Fail, you can try that transaction again later. All right. So the big point of all of this is, once again, is that you can have multiple transactions going at the same time. If those transactions conflict with each other, meaning like one is holding an exclusive lock that the other one needs, the other one will wait until that one is done. This is actually something called deadlock if you're waiting forever, but we'll talk about that again much later in the class. Okay, so multiple choice question time. We've been talking a lot about database elements when you're trying to read from database element A, write to database element A, and so forth. So wait, I haven't been very explicit about what actually is a database element. What level of granularity should a database management system like SQLite use to lock? Should they lock a particular value within a row? Should they lock the row itself? Should they lock the entire table? Should they lock the entire database? What do you think makes sense to lock? And so the correct answer here is really any of the above would be perfectly acceptable answers, right? The important thing is that no two parts of the database can ever control or can ever manipulate the same database element at the same time. And in reality, locking the smallest part of the database that you can is better because it would allow for multiple different transactions to change different parts. Because if you lock, for instance, the entire database, it means you're only allowed to ever have one writer to that database at any point in time, even if they're only touching different tables. Or if you lock an entire table, it means you're not allowing two different transactions that are only writing to different rows to transactions that are writing to different rows would conflict with each other. Or if you lock the entire row, it means transactions that are only writing to, for instance, different columns in that row would conflict with each other. So what we'd love to do is have it always be on the smallest level possible, which would be the value here. But actually what SQLite does is it does a much simpler thing and just says, I'm going to lock the entire database. And you might go, wow, that seems really crude. And in reality, it is. But the way that SQLite is intended to be used is usually not a whole bunch of writers to the SQLite database. If you have a whole bunch of writers, you have a whole bunch of different queries that need to write things to the database. Usually a different type of database management system, usually things like MySQL and things like that, are meant to handle those use cases a bit more. SQLite is primarily used as more of a, you write to it some of the time, but most of the time you're just reading, and so locking the entire database for a write isn't actually that expensive. And actually for the purposes of this class, and especially for the purposes of Project 4, where you're going to be writing code to handle transactions, it's much easier, and what you guys will be doing is locking the entire database instead of any smaller part of it. All right, so since the SQLite locks the entire database, let's talk about some of the different states that the database can be in. And now this is taken from the SQLite 3 documentation. I'll provide a link in the description to it, or you can Google it yourself to look at SQLite and how they handle locking. So the first and simplest state of the database is that there are no locks on the database at all. This means nobody is reading or writing to the database. And this is the state where it's basically no transactions are currently ongoing. The next state of the database can be, it's in the shared mode. Now what does this mean? It means that some number of processes, one or more, are holding shared locks on the database. And so there can be many shared simultaneous readers because that's the whole point of shared locks, that they don't block reads. However, the rule is if you're in the shared lock state, no other threads, no other processes, no other transactions are allowed to write to the database because there are people reading from the database right now. Another state, which we haven't really talked about, is the reserved lock. And this is a kind of another type of lock that's in between shared locks and exclusive locks, which basically means I would like to get an exclusive lock at some point later than now. Okay, it's saying I intend to do writes to the database. If I can get a reserved lock, it means nobody else is allowed to get an exclusive lock. No new shared locks are going to be allowed because I really want to be able to write my modifications to the database. So please tell people to stop getting new shared locks. We'll talk about this in a little bit. You're only allowed to have one one reserved lock, just like you're only allowed to have one exclusive lock. And you're not allowed to ever have an exclusive lock and a shared lock at the same time. This is basically like saying, I would like to get an exclusive lock, but I'm willing to wait until the processes that are currently holding shared locks finish and end. And it also means, hey, don't give any more new shared locks because I want to get an exclusive lock at some point soon. The next lock state is pending, which basically means that the database is waiting for all the currently shared locks to get out, to finish their jobs, to roll back or commit, so that we can move to the exclusive lock state. And so this is saying, hey, shared locks, people, finish up your job. I'll let you finish, but no new shared locks until I'm allowed to get my exclusive lock and do my write. And then the last one is that exclusive lock state. And so this is saying there's only one allowed, and the transaction that has this exclusive lock is then finally able to actually do its write to the database. And so SQLite works really, really hard to try to not ever be in this exclusive lock state, because when you're in the exclusive lock state, nobody else is allowed to read, nobody else is allowed to write. It really makes everybody else wait for this one transaction to finish. And so SQLite works really hard to try to make sure that this exclusive lock state is as short as possible so that you're not holding up other transactions. Okay, so those are the 5 states of the database. You don't need to memorize them, but it helps you walk through kind of the different levels that the database can be in terms of from being very permissive to saying, okay, transactions can basically get at and start doing whatever they need to do immediately, to the other state where they have to wait for other transactions to finish. Alright, so in addition to those locking states, SQLite has 3 different transaction modes. And I've only been showing you the default mode, which is called deferred. The way that a deferred lock works is it requests a shared lock the first time it tries to read. So the transaction starts off, it doesn't have any locks, and when it tries to read, aka do a select statement, it says, can I get a shared lock please, because I'm trying to read from the database. And the first time it tries to write to the database by doing any of the insert, update, delete sorts of statements, it then says, hey database, can I please have an exclusive lock? And so it only requests the locks when it needs them. That's why it's called deferred. However, there's 2 other modes. Another mode is called immediate. What the immediate mode does is it says, hey, right when I start, right during the begin command, can I have a reserved lock, please? And what it does with this reserved lock is it's basically telling the database system, hey, I intend to do a write, and I want to, from the point from when my transaction begins, not let anybody else get shared locks. It's basically saying, I'm going to intend to write. Please tell everybody else no new shared locks so that eventually I'll be able to actually make my write. I'll be able to actually upgrade my reserved lock to an exclusive lock. That's sometimes called promotion. And what it will do is it will fail or wait, depending on how long the timeout is, if another transaction is already holding the exclusive lock. So it's saying, okay, if somebody else already has the exclusive lock, this transaction won't be able to start until that exclusive lock has been released. It also needs to request an exclusive lock prior to actually writing to the database. And the other important thing that's really easy to forget is when a transaction when a transaction that has a reserved lock tries to commit, it needs to promote its reserved lock to an exclusive lock. And the last mode is the exclusive transaction mode. Right when the transaction begins, it asks for the exclusive lock. It says, hey, I want the exclusive lock right now. And it will do is it will fail or wait if another transaction is holding any other type of lock. Because once again, you can't grant exclusive locks if people have a shared or exclusive lock. So it will wait or fail if it waits too long if it can't get that lock. And then the other important rule is all transactions release all of their locks when they commit. Once you've committed, you don't get to hold any more locks. You start off fresh again. All right, so how do you write the commands to do these different types of transaction modes? Well, you say begin transaction, and this by default is really the same as the next one, begin deferred transaction. You can also say begin immediate transaction, begin exclusive transaction, and then the way that you commit and roll back is the same regardless of your transaction mode. Okay, so multiple choice question time. What is the best transaction mode? So this is a little bit of a tricky question. So first off, default and deferred are the same thing. So if you like one of them, that's great. So let's talk about the pros and cons for these different transaction modes. There's a reason why SQLite provides these three modes. So let's talk about them in reverse order. So when would you want to be in exclusive mode? Well, you want to be in exclusive mode if it's really important that you do your read and write immediately, and it's really important that you fail immediately if you can't do it. So if you are trying to add to the database and you want to very quickly either add it to the database or fail, you would put yourself in exclusive mode because it will immediately attempt to get that lock, and if it can't get the exclusive lock right now, it will quit. So if it's really important that you need to do writes or reads quickly and would like to know if they succeeded, you would get an exclusive lock mode. What about immediate mode? Well, immediate mode is basically saying, give me a reserved lock because I intend to write later. And it means that from the point that that transaction starts, the database should start finishing up the shared locks and making the other new shared lock requests wait. So it's basically like saying, hey, this person is like a very important transaction that we want to allow it to do its right eventually. But I don't want it to be waiting forever to get that exclusive lock to basically close the door to new people coming in. And so the things you'd stick in the immediate mode are things that don't need to be done immediately, but things that you'd like to be done eventually. But of course, because you're granting the immediate transaction mode a reserved lock, it means it does slow down the database somewhat because you're not going to just allow the new readers to come in, do their job, and finish. You're just saying, hey, hold the door, I want to get the exclusive lock soon. But the deferred mode, or the default mode, is most of the time the one you want. That's why it's the default, which basically says, I'm not going to request any locks that I don't need until I actually need them. And for most transactions, which are mostly just reads, this is exactly what you want. They won't ever need a reserve lock. They won't ever need an exclusive lock. So why ask for it? And so generally, you want to be using the default mode unless you have a compelling reason. For instance, you have a write that's very important that you do, you put it in immediate mode. You have a write that's very important that is done quickly, you'd stick it in exclusive mode. But most of the time, you would stick to the default, the deferred mode.